All right, hello guys, Mr. Holly. We're going to be looking at your problem set. So question number 1 asks about a cranberry juice blend that is mixed in a ratio of cranberry to apple of 3 to 5. So cranberry, 3 parts cranberry, 5 parts apple. If I was to complete this table, assuming that they are proportional as it tells us here, I would actually use a scaling up method right now. I would not look for the constant yet. I would just scale this up to create this table, because we know that proportional relationships scale up at the same rate. So if I want to double this, like times 2, then I would get 6 cups of cranberry and 10 cups, or times 2, excuse me, 10 cups of apple. And if I want to triple this, I would get 9 cups of cranberry and 15 cups of apple. Now we're at the point though where we are asking why are they proportional, and we need to prove that there is some K, some constant. Now given this ratio of 3 to 5, like if we say 3 to 5, whenever we do this, whenever we find our K value, our constant, we do that with the Y variable on top and the X variable on the bottom. And because of that, I'm going to label this 3 to 5, I'm going to label this Y and X. Cranberry is Y, apple is X. So let's look at, what is my relationship? What is the K value that I have to multiply X by in order to get Y? X is 5, I need to multiply that by 3/5 to get 3. This is 10, I need to multiply that by 3/5 to get 6. 15, I need to multiply that by 3/5 to get 9. So I can see that my K value here, my constant, is that I'm multiplying by 3/5. So Y is equal to 3/5 X. And I could use that for any value now. Apple juice, if I wanted to have 50 parts of apple juice, well, I could come up here and say 50 times 3/5, I would have 30 parts of cranberry juice. So 3/5 is my constant. It is the constant of proportionality that connects my amount of apple juice to my amount of cranberry juice. All right, now if I look at number 2, I'm asked the question that John is filling a bathtub that is 18 inches deep. He notices that it takes 2 minutes to fill the tub with 3 inches of water. All right, now I'm going to write this rate as 3 inches every 2 minutes. And the big reason for that is that time is typically going to be your X variable in any, as you go forward in math, you're going to be thinking about how much per minute, how much per mile. Think about the rates that you know in real life. Miles per hour, time is the denominator. Meters per second, time is the denominator. Most of the time, whenever we're talking about any type of rate or any time relationship between distance and time, or something and time, it's usually how much happens per allotted amount of time. So per minute, per second, per hour, those are the types of things that we're looking at. So we're usually going to put minutes, seconds, hours, that's usually going to be in our denominator. And like I said above, that makes this Y, that makes this X. So what do I need to multiply X by in order to get Y? Well, 2 times 3/2 is equal to 3, right? So that would mean my Y equals KX. Y equals 3/2 times X. In order to get Y, I have to take X, which is 2, multiply it by 3/2, and I get Y. And if you look, your rate is right here. Like they actually they have given you the rate. That is your constant, the rate that they give you. Now, potentially it could have been simplified, like if they had said 6 inches in every 3 minutes, then we would say 2 inches per minute. But in this case, this is a improper fraction or mixed number that we would have to use. It doesn't simplify to just an integer. So 3/2 is our rate. Okay. Now let's actually answer the question. 18 inches deep. They want to fill this thing in 18 inches, or excuse me, they want to fill 18 inches, and they want to do that in 10 more minutes. So if it's already been 2 minutes, that would be a total of 12 minutes. So in 12 minutes, is y going to be 18? 3/2 of 12? Yes. Y 18 inches in 12 minutes. This equation is true. 3/2 of 12 is equal to 18. So yes, that works. They are correct. And it says to explain, you could write something like, the tub is filling at a rate of 3 inches for every 2 minutes, or 3/2 inches per minute. So in 12 minutes, the tub would have 18 inches of water. That's an explanation that would satisfy this problem. So, all right, thank you guys.